In this video, we're going to look at some SQL queries of the NorthWind database that the W3 Schools has available. And so they're mainly the queries we're going to look at are going to be joins. We're going to pick records that are relating more than one table. So first thing to do, I think, is to understand some of the relationships between the tables or the entities in this database. So we have here sort of like a customer and an order. And we are always looking for, we always make our relationships sort of make our relationship statements in pairs where we always start with an instance of the customer table. So when I say a customer, I really mean an instance of the customer has one or many orders. Well, a given customer may make many orders, and then an order is placed by one customer. One customer is going to sort of per order. So then let's look at, so this is the w3schools.com/SQL, and I'm on the SQL_select.asp page. But eventually, now I just want to go to try it yourself and look at the tables. So if we're right that that a customer has many orders, but an order is placed by one customer, then the one in that case will have a foreign key. So we should, in the order table, we should see that there is a customer ID as a foreign key in that table. So that makes sense. So we can imagine that we were designing this database, sort of forward engineering it. So if we said a customer has many orders, but an order is placed by one customer, then we know that the order table should have a customer ID as a foreign key because it had in those statements, it was the one with the word one. Or we can sort of reverse engineer and say, when we look at the orders table, we can see that, an order is placed by one customer. We see some other foreign keys here in the order table, the employee. So the order is placed by one employee. So an employee takes an order, and there's only four, and an employee may take many orders, but the order is taken by one employee, and the order is shipped by one shipper. What else do I have here? The next thing down in my list is an order includes. So if I'm going to order, depends on your definition of order, but in this database, an order contains many products, and a product may be included in many orders. So that's telling you that I will not find in order a product ID. I did not. And in product, I will not find an order ID. There will be some other table, I'll often call a bridge table, which will connect these and will have both order ID and product ID. And that is indeed the order details table. This is sort of like a line within the order or a detail of the order. It's a sort of standard in a transactional relational database. It's kind of a standard table and appears. And here's this table with order ID and product ID connecting, making this many-to-many relationship. And then let's finally do what we already sort of looked at this one, did we? A category includes there are many products falling under a particular category, but a product, it belongs to, we're going to say, one category. So the way our categories work, or the NorthWind categories work, there is one. So if we look at product, it should have a category ID. So let's look at product. it has a category ID, it has a supplier ID. So the product is made by one supplier. A supplier may make many products, but a product is made by one supplier. And the same for categories. A category may have several products under it, but a product fits under one category in this database. Okay. And we need to know that kind of information for making our joins because our joins involve more than one table. So let's look at this table and category idea. Sort of this first uh, join, this first uh, query we want to do, and it's involving both. And I'm going to first show you uh, what's called a Cartesian product. And then I'm going to turn the Cartesian product into a join. And then I'm going to use a different notation, sort of a built-in join notation. Okay. So if we want to relate products and category, this sort of last example that we just did, then we can say select star from products and we want more than one table. I'm just going to put the from on a different line. And we've seen where we had more than one, where we were listing properties, but we had more than one. And so then we separated them by commas. Here I'm going to separate the tables by commas. So I'm going to be dealing with products and categories. And I'm not going to say anything more than that. I'm just going to say, give me products categories. What does that do for me? That gives me 616 records. Okay, so there were 77 products in 8 categories. So what this does is makes every possible combination of a product instance and a category instance. And doesn't it's not caring is that product fit that category. That's not what this does. That is just giving me all possible combinations. So if I whip out my calculator and I've already done the calculation, if there are 77 products and 8 categories, then all of the combinations are 616 of all the combinations. The first product in all the categories, the second product in all the categories. Okay, so this is not a very useful thing, but it's a Cartesian product. It's a step along the way. But we see here that here was product one, which belonged to the category ID appears twice. So one time it said products dot category ID and categories dot category ID. So it's a repeated field. But one time it belongs to the product table, one time it belongs to the categories table. And you see here that it was that the category ID on the products table was one and the category was one. And then here the product category was one, but now we've moved on to category ID two in the categories table because we're just making all the combinations. But what we're interested in is when they match. So let's add a where clause, and I want those two, uh, and because they both appear, I've got to include them both. There are two category ID fields. If I'm working with products and categories, both of them have a category ID. And so I need to make distinct with the name of the table. So this is the products dot category ID, and I want that to equal the categories dot category ID. We got to get our capitalization right, and I screwed it up there. That should be a capital C. So I'm selecting all the fields. I can come and pare down the number of fields I'm getting, but I'm going from products, comma, categories, both tables. But now I'm going to select out only the times when the products category ID matches the categories category ID. So I'm getting the category information that corresponds to that product. So if I run that, now I have 77 records, and I can see that chartreuse vert is a beverage. Here's the category name over there. So that then is what we call uh, a join. Um, you can do different kinds of joins, but typically you're joining on a foreign key from one table, matching a primary key from the other. And then if you come along and select the fields and get rid of this a weird duplication, then you'll have what you call a natural join. Sort of start off with the Cartesian product, uh, make the foreign key from one table equal the primary key from another table, and get rid of that duplicate field in your list of fields, and you'll have a very useful thing in databases called a natural join. And so there's a um, different way of doing that, and that's known as the inner join here. So we're going to make an inner join. What's their example of an inner join? Um, here's their, so where they're pulling out, they're doing product and category as well, and they're saying, but they're specifying some fields, pull out the product ID, the product name, the category name, and then from products, and then they're not doing the comma and the where that we just did. Do I still have it? So we did products, comma, categories, where the IDs. This is a different notation, but getting the same thing where you start with one field, products, and you say you're going to take the inner join, and then the second table, categories, and then instead of saying where, you say on. Um, you're making the inner join from products to categories on the products category ID matching the categories category ID. And so that was the first example I wanted there, and that is their example. So there was not much to it. But now let's do um, another one just to get the hang of it and not just rely on them doing it for us. So let's get the product information and the supplier this time. So now product ID and product name will keep, but we're going to switch over to, what did we say? Supplier ID and supplier name. Oops. Supplier ID and supplier name. And I'm getting it from products. And this time I'm going to go on to suppliers. And you've got to know the names of the tables and the names of the field. And in this, at least this version of the NorthWind, the tables tend to be plural, have S's on the end, and then the categories tend, or the properties tend not to. And there's also the tables tend to start with a capital letter, and then the field names, the properties are often compound words using a camel case. So two words, every new word starts with a capital letter. So products, and we are looking for it to match on supplier ID here. Now I'm already going to see now that I'm going to have a mistake because supplier ID. Now I'm going to ask them to supplier ID match, but I'm still not allowed up here to say just supplier ID. Even though I'm going to insist down here they're the same, it's still going to tell me I don't know which one you mean. And, and I will say to it, it doesn't matter which one I mean. I'm asking for them to be the same, but that doesn't matter. Okay, I have to spell supplier correctly. I need to specify here, or it's going to yell at me. So I will ask for the supplier ID. Product ID is okay because that doesn't belong to both tables. But the supplier ID belongs to both tables, and so I've got to say which one I want. Again, even though I'm asking them to be the same. And then here are my 77 products. with their supplier. So first several are supplied by exotic liquids, then we move on to New Orleans Cajun Delights, etc. And let's do one more for good measure, and then um, or do I want to? No, I'm going to wait because I think on my next example, I'm going to do both an inner join and an outer join. So I'll save that for the next video. So that's what we're doing. So we wanted to make sure we understood the relationships in to do a join. A join involves working with the relationship between the entities, between the tables. So we did a little exercise to make sure we understood them, particularly their multiplicity. Then we looked at that intermediate thing, which is not very useful, called a Cartesian product. We saw how we could use a where clause to pick out the meaningful rows from the Cartesian product, and that was a join. And then there is this other notation within SQL for an inner join. And next one, we will make a distinction between an inner join and an outer join. So you'll understand that word, why we're seeing that word inner. All right, that's it for this one. Thanks for your attention.